Hi there, my fellow intellectuals. We're going to be streaming and recording on twitch.tv. I'm going to be doing some integrals on Wolfram Alpha's problem generator, just for some fun, because I haven't done integrals in a while, and I love doing integrals. It's one of my favorite mathematical problems to do. So we're going to warm up with some U substitution on, the beginner difficulty. So let's see if I can even do this without even thinking about anything right now. So we have 8/5 e to the 7t plus 6. So what we're going to do is that we're going to bring down a factor of 7 from the exponential, right? Because if you have an e to the kx dx, right, you get 1 over k e to the kx plus a constant. So we're going to have an 8 over 35 in the answer. So 8 over 35 times e to the 7t plus 6 as a constant. Nice. So now we're on to the second one. So we have 8/7 7x plus 1 dx. So if we think about this, the integral of a sine function is a negative cosine function. And we have an 8 over 7. We're just going to push that outside. We're not even going to think about it. And if we have a constant multiplying the argument, right, this is just equal to negative 1 over k cosine of kx plus c. So we should have 8 divided by 49 as the prefactor on this integral. So we should have a negative 8 over 49 because of that. Same arguments, I have an x plus 1 plus a constant. So far, so good. So let's just do one more on the beginner difficulty, and then we'll switch it up to the intermediate one. So we have 7 over 6. So this is pretty much the same integral we had before. So we have 7 over 42. 7 over 42 is 1 over 6. Right? So we should have 1 over 6 minus 1 over 6. Almost forgot that again. Times cosine 7x plus 2 plus a constant. Good. So now we've gotten the u subs out of the way. Let's go into something a bit more difficult here. Let's go to intermediate. Okay, so we have integral 3e the x over 7 e the x minus 6 cubed. So let's put the 3 sevens on the outside. Now we're going to let e to the x minus 6 be our u, right? So we'll have e to the x dx be our du. So essentially it becomes an integral of 3 over 7. We have du over u cubed, which is just minus... Wait, so this is... double checking here. This is... sorry about that. So this is u to the minus 2 over minus 2, I believe. So I should have a minus... Sorry, 1 minus. So I should have a minus 3 over 14. So I think I have a minus 3 divided by 14 times... Now I have to have u to the minus 2. So that's pretty much 1 over e to the x minus 6 squared. I think. Plus c. Bingo. Awesome. Next intermediate one. 3 halves e to the 4x to the 5th minus 5x to the 4th with respect to x. Well, we have a 4x to the 5 minus 5 in this exponential here. We should let our u equal this entire expression. And that means our du will be 20x to the 4th dx. Okay, so we have a 3 halves. Let's push that outside. And we should have a 20x to the 4th. So we should divide that by 20 on that side. So we should have 3 over 40, I believe. 3 over 40. And now the integral becomes essentially e to the u. So I believe this is e to the 4x the 5th minus 5 plus c. Now let's double check that. So keep the 3 over 40 outside, e to the 4x minus 5. That should become 20x to the 4 Am I doing that correctly? 20x to the 4? Yeah, I think that's correct. Let's just go with it. Awesome. So we're going to do one more on the intermediate before we step it up to the advanced. So bring the 4/3 outside, sine 2x, e to the cosine 2x minus 5. So we'll have cosine 2x minus 5 be our u. du is going to be a minus 2 sine 2x dx. So we have a minus 2. So we should put that downstairs, right? So we should have a 4 over a minus 6, I believe, on the outside, which is a minus 2 over 3. So let's double check that again in my head. So if you use cosine 2x minus 5, du dx is going to be negative sine 2x dx, right? Negative sine 2x dx. So I should have a minus 2 over 3, I believe, on the outside. So minus 2 over 3. Now this is just going to be e to the cosine 2x minus 5 plus c. Awesome. So now we can step it up to the advanced difficulty. So, okay, we have 5f x secant squared x squared plus 4 with respect to x. So we should let u equal x squared plus 4, right? So u is equal to x squared plus 4. And then the du is just going to be 2x dx. So du over 2 is equal to x dx. Right, so we should have a 5 over 4 on the outside because that 1/2 is going to multiply the 5 halves. So we have a 5 over 4. Now we have the integral of secant squared. It pretty much just becomes the integral of secant squared of u, and that is just going to be a tangent, right? So that's going to be a tangent of x squared plus 4 plus a constant. Awesome. Next one. Oh my goodness. This looks absolutely horrifying, but I think we're going to be okay because if I remember correctly, I believe it's d by dx arc sine of x, right, is equal to 1 over square root 1 minus x squared, because that's what we have in the denominator there, right? So if we have, oh boy, whew. This is not an easy one. So we have a log. So let's think about this one. So we have 2/3 on the outside. We got a log. We have, I'll write this arc sine. I don't like sine inverse. So arc sine of 5t over the root 1 minus 25t squared. I should probably see this one a little bit more quickly. But if I know this relationship here, that means we should probably let u equal arc sine 5t, which means du dt is equal to 1 over 1 minus 5t squared, which is what's in the denominator there. Bring a dt on that side. So that becomes our du. So this essentially is our du. Okay, so essentially we have a 2/3 integral log of u du, and the integral of ln of u is just this 2/3 u ln u minus u plus c. Okay, so writing all that out, that's 2/3 u is arc sine of 5t, arc sine 5t log arc sine 5t minus arc sine 5t plus a constant. Alright, that's what's going to be my final answer if I was playing Wants to Be a Millionaire. Arc sine 5t times log arc sine 5t now minus arc sine 5t, close that parentheses, plus a constant. I hope that's right. Let's see, wait. You know, I think there's a factor of 5, right? Shouldn't there be a factor of 5 here? I think there should be a factor like this arc sine of 5t, so we should kick out a factor of 5 right here. I think that's right. So I should actually have probably a 10 over 3 on the top. Yeah, I think it's going to be a 10 over 3, not a 2 over 3. So let's see. Oh, doesn't understand my answer. So what don't you understand? So it doesn't like the fact that I closed this, maybe? So I have one parentheses here. Log, oh, maybe another parentheses right there. Okay, let's try that. That is not correct. Okay, fine. Let's see, hint. Now that's exactly what I had here. So why am I not correct here? So I have a 5. So 5 over root 1 minus 25t squared. Okay, so u is equal to that, du is equal to... Oh wait, I think the 5 should go on the should go downstairs. It shouldn't go upstairs. Sorry, it should be a 2 over 15, not a 10 over 3. My mistake. I was putting it in the wrong place. 2 over 15. Of course. Of course. How could I miss that one? Alright, question 9. Find the integral. Secant squared 6x over 2 tan squared 6x plus 1. So the derivative of tangent... Wait a minute. Wait a minute. Tan squared 6x plus 1, that's just secant squared of 6x. So it's just the integral of 1/2 dx. Come on, man. Like, because we know that tan squared of x plus 1 is equal to secant squared of x. So the denominator is just secant squared of x, so that just cancels. So we have 1/2 dx, so it's just x over 2 plus c. Right? Did I just go too fast in my head? X over 2 plus c. Yeah. Come on, you're trying to trick me. That was just such a... That was such a trick question right there. Next problem. Find the integral 3/2 e to the 6t secant squared e to the 6t dt. This should be pretty easy. This is just going to be 3/2 e to the 6t, so we'll have u is equal to e to the 6t dt, so I should have 6e to the 6t dt divided by 2, so I should have 3 over 12. That's 1 over 4, right? And then I'll have secant, so that'd be tangent e to the 6t plus c. Wow. I was afraid that would be a bit too fast, but it looks like I could handle it just fine. Okay. Oh, not you again. Not this one again. This is the same one that gave me issues last time, but... Alright, so if you have a log of sine x plus 5, you just let u equal sine x plus 5, du is equal to cosine dx. So you should have 4 over 7 log of u du. So 4 over 7, this is the same problem as last time that gave me trouble. 4 over 7 times... it's like u log u times minus u, so it's u, so it's sine of 5x plus 5u. I'll put a bracket around this so I remember. That's u times log of sine x plus 5. So that's u times log u minus sine of x minus sine of x plus 5. Like that. Yes. Plus c. Thank you. See, that was giving me issues before, but now I got this one. So now integrate e to the arctangent of tangent inverse. Sorry, 3 to the arctan 3t. Okay, good. So arctan's derivative is 1 over 1 plus x squared. So arctan of 3t should give me 3 over 9t squared plus 1. Okay, so I should have a 1 over 9, I believe, on the outside. 1 over 9, because there's a 1 over 3 already there. And this is just e to the u du, so this should be e to the... I'll write this as arctan 3t plus c. Nice. So I think I'll go up to maybe 15, and then we'll call it for now. So let's just see if we can crank out these last few integrals. So find the integral 3e sine inverse 6x, so 3/2, push the 3/2 outside, sine inverse is 6x, so I should have a factor of 6, so bring it down, that's 3 over 12, which is a 1 over 4 again. 1 over 4 times e to the, it's just the arcsine of 6x, I guess, again. Let's see. Nice. All right, one more to go. One more to go, and we'll call it here. So integrate 2 secant squared log 2t plus 1 over 3t. So we have a log 2t plus 1. So we should have log of 2t plus 1 should be our u, right? If u is equal to log 2t plus 1, du dt is equal to 2 times 1 over 2t. So it should just be 1 over t dt. So we have 2/3. So I think the 2/3 is going to stay on the outside. 2/3 times, now we should just have a tangent of log 2t plus 1, because essentially we're just doing an integral of secant squared integral log of 2t, right, plus 1, close that, plus a constant. Nice. And that is the 15th integral I've just done. So I hope you've enjoyed watching this stream, watching this recording post on YouTube. So if you like this sort of just problem solving with music in the background on Twitch and on YouTube, let me know in the comments, and I will consider doing more of these in the future. So until then, I'll see you guys later.